Okay, today is a review for the polar test. First of all, let's talk about polar by making a dot. That sounds complicated. You're going to make a point for this polar location that I tell you. All right? Your point is at 3, 11 pi over 6. Could I have made it more complicated? 3, 11 pi over 6. That's a place in polar. Of course, this is r, theta notation. So you figure out where that would be, put a dot, and then label it with like, okay, here's the radius, and etc. And then I'd like you to figure out 3 other ways to write the location of that point. Write them down, and I'm going to have you compare with other people in just a second here. Okay, I'm going to pause for a second. Okay, for those of you that are overachievers and already done, the next question is, what are the rectangular coordinates for this polar point? If you've got the equations memorized for that, cool. Otherwise, you can do it from the picture. It's not impossible to find x and y from the picture that you've drawn. Either way, find me the rectangular coordinates next. So this could be done with a positive angle. It's right there, which would have been 11 pi over 6. But the negative angle that would do the same thing would be negative pi over 6. Raise your hand if you had that one right. Okay, good. Then option B is you could have gone over here. Why would you want to go over there? Because then when you use a -3, it would bop you back over here. So I didn't draw that terribly straight, so I'm going to straighten that out a little bit. And then by the vertical angles in geometry, that would say that this angle and this angle would have to be the same, and therefore this is pi over 6 right there. But to get there, I need to do 5 pi over 6. Did you say 5 pi? Here's a second here. 5 pi over 6, comma, -3, comma, 5 pi over 6. Raise your hand if you had that one right. Okay, good. And then I suggested that we not do a negative side and negative angle. So instead, how do you get a really big angle for the, this is just kind of like a little formula for it. Mr. B, do you know that formula? Yeah, I just take, actually I could take any of these and I got to add 2 pi to the angle. Okay, so I would just take the original one then, which is that, add 2 pi to the angle. But wait, they don't have a common denominator. So you make it have a common denominator. And you say plus, instead of just 2 pi, you say 2 pi over 1 times by 6 makes 12 pi over 6. 12 pi over 6 plus the 11 pi over 6 makes 23 pi over 6. Who had 3, 23 pi over 6? Raise your hand if you did. Okay, awesome. Questions? Yes, sir. Yes, negative is an option, but here's the thing. They're going to give you choices. They're going to say, I want you to write me one where the r is negative and the theta is positive. And then you'll have to do that. So you won't have to do a negative one. It sounds like you have one. Do you want to tell me what it is? I'll tell you if it's right. All right, so all I need to do is get to this dotted line here by using a negative angle. So this negative angle would be -6 pi over 6. That would be right, -7 pi over 6. Okay, good. All right, my point was I wanted to make sure that you guys knew that you're not going to get to pick which one of these you do. You will be told, I want you to do it with a positive r and a negative angle, or want a negative angle and a positive r, or a negative and a negative is another possibility. All right, moving on. You were supposed to get that same point in rectangular coordinates then. So here it is. And what's the rectangular? The x and the y. You can do it from the picture, but I'm going to choose not to do that because there's a faster way. Did you remember that if it's 3, 11 pi over 6, that you could use this r cosine theta and r sine theta? Remember, raise your hand if you knew that. Okay, good. Now, what is r? It's 3. So I can put a 3 there. Okay, so it's 3 times cosine theta and 3 times sine theta. Well, what's cosine theta? Cosine of 11 pi over 6. Be careful now. All students take calc. Cosine is positive down there. Now, I'm kind of mixing polar and rectangular right now, so I want to not do that. I'm going to draw a separate graph to do my all students take calc thing here, because all I'm trying to figure out right now is what the cosine of 11 pi over 6 is. It doesn't matter that it's polar or not. I'm going to go back to the old school rectangular graph where this is x and this is y, and if this distance is 3 and this angle right here is pi over 6, then I basically got the 30, 60, 90 triangle going, where that's a 1, but careful, negative 1, and that's a 2 here. Now you might be saying, but wait a minute, sir, you just said it was 3. Because I right now am just trying to figure out the angle. I don't care what the radius is. I can always change the radius later. So negative 1, 2, and square root of 3 goes there. And now I can do sine and cosine. Cosine, it didn't matter with a negative, but the sine, it did. You get what I'm saying? Some of you guys probably screwed up your sine. Cosine is root 3 over 2. But the sine is opposite, which is negative 1 over 2. So you should have said 3 root 3 over 2, comma, 3 times negative half is negative 3 over 2. If you missed that negative there, it's because you didn't be careful with where this was. 11 pi over 6 is not the same as pi over 6. You're down here in this quadrant, and sine is negative down there. Okay, so what's next? Well, last night you learned about graphing, and here would be a typical problem. R equals cosine of theta. Now, you can make it more complicated, of course. Let's just make it a little more complicated. We'll say 4 cosine of theta. So whatever you would have had when you had done cosine theta, you get that answer. Let's say it had come out to root 3 over 2, and you times it by 4. Would you please make me an R theta table for 4 cosine theta? Hint, you want to pick thetas that are nice, and you will need 6 of them. Why? Because we're making curves in a whole. If I give you like 3 dots, here's your 3 dots. Do you know what the graph looks like? It's really hard to tell if it's like a circle going around here, or if it's, I don't know, it could be a triangle, but the 3 dots aren't enough. You need like 6 dots. So once you see 6 dots for this cosine, you'll be fine. Okay, again, right now, find me 6 points. That'll force you to use some of the less common ones, like pi over, or 3 pi over 2, or 2 pi, or maybe 120 degrees, which would be like 260s, which is 2 root 3s, or 2 pi over 3. I spied with my little eye something that should be on my desk right now. Okay, I'm revising this a little bit and telling the kids I want them to tell me these 3. If they've already done them as part of their 6, cool. If not, I guess you'll have a few more points than 6. Okay, so what is cosine of pi? Well, here's pi, and cosine there can't have a triangle. So therefore, I just need to know the point. It's negative 1 comma 0. Last hour I made a mistake and called it 1 comma 0. Oops. That's kind of thinking along. I get if we were doing a polar graph right now, that would be 1 comma 0. That'd mess with your head a little bit, wouldn't it? Okay, back to, if we just think about angles, that's where that angle is. And now, what is the answer? Cosine's the x, negative 1 is the answer. But before I slap it in this spot, I have to do what to it? Multiply by 4. So it's actually negative 1 times 4 is negative 4. Raise your hand if you had that right. Okay, now how are you going to graph negative 4 comma pi? Hint, now I'm changing to a polar graph. It's different. How do you graph negative 4 pi? Well, first of all, you figure out where pi is. Pi is over here, so I'm on a ray that's headed this way to start with. Then I go out to 4, whatever you consider your units to be there. Now I'm at, do you get, I am at this spot, I am at, in polar, 4 comma pi. Is that where I'm supposed to be? No, this is what I'm supposed to be graphing. So where do I move that point now? Over here. Boop. Do you get that's where part of my graph is for this? All right, let's do another point. 2 pi over 3. I'm going to make a rectangular graph now. Here's where 2 pi over 3 is. And that angle is 2 pi over 3. That leaves 1 left. Pi over 3 is right there. Then, if that's a 60, then this angle is a 30, and that makes this a 1, 2 square root of 3. And this is negative, and that's kind of important. So then, what is cosine of that angle? Cosine is adjacent over hypotenuse. It's negative a half. What is 4 times that? Negative 2. Now, when I graph this, do you get, I'm first going to go to 2 pi over 3. 2 pi over 3 is like right there. And that's an angle. And I'm heading out 2. But then I go out 2, but then I don't actually plop it there. That's where 2 comma 2 pi over 3 would be. I got to go over here and go out what I would consider 2 and put a dot right there. Remember, start by graphing it with positive radius. Then, when you're all done, you just have to go straight the opposite direction. I was over here, and so I go straight the opposite direction over to there. I get what you're saying. It's not going to be perfect. You're not going to be perfectly accurate. But when we're done, you're going to see something form over here on the right-hand side, and I think it'll make sense to you once it's all done. If you had a really complicated graph, yes. Like, if, for instance, if it's a spiral or something that's really complicated, you might not be able to tell. But we're graphing things that are usually circles or simple curves. Don't worry about that. Because I get what you're saying. What you're saying, I think, is what if I had to connect those dots and I didn't know how to do it? Okay, don't worry. It's not going to be that complicated. All right. So 3 pi over 2. I'm going back to rectangular for a second. This is where 3 pi over 2 is. So what's that point? 0, negative 1. And what is the cosine of it? Cosine, ka, adjacent over hypotenuse, but that's for a triangle. Cosine is x. There we go. It's 0. And 4 times the 0 gives me 0. Got a hint for you. If you ever want to graph 0 anything, it's just the origin. There's a dot right there. Okay? How many of you know where this graph ends up? It's basically a circle over here. How do I know? Grab your graphing calculator. Take your graphing calculator, type in r equals, and that'll be on the y equals screen, 4 cosine theta. Graph it, you'll see. It's over on the right-hand side. Nope. That would be way too easy. Got it graphed? If it looks a little eggy shaped, it's because your calculator, since you've been graphing, since the beginning of you using this graphing calculator, has always been stretching your graphs. You just may not have known it before. Because there's more tick marks on the x-axis than there is on the y. And therefore, things get stretched. If you want it to look right, hit zoom 5. That makes it have equal distances on x and y, and it makes your graph like the way it's supposed to be, which is square. So now does it look like more like a circle? It should. Not very egg-shaped, more circle-shaped. Okay. There's the basics of graphing. I feel like we should do one more like that and see if you can handle it. What if I had 2 sine theta plus 1? And I'd like you to just find me 3 points on this, just because I don't want to take too much time on it. Find me 3 points on that. Don't use your calculator. We all know that that could do it in 2 seconds. Can you find me 3 points on this graph? Well, you get to pick the thetas, or technically you could pick the r's, but it'd be kind of hard to do the r thing. A lot easier to pick the thetas. So I'm going to pick thetas that work nice, like sine of 30. It's my favorite thing, also known as pi over 6. I should probably get better about rating these in radians. I think it's going to ask you for radians on your test, so let's do it in radians. Okay, so sine of 30 is a half, so I just put a half here, right? No. Sine of 30 is a half, but that means this is a half, which then means 2 times a half plus 1. 2 times a half is 1, plus 1 is 2. So I don't put a half here. I take it and times it by 2 and then add 1. And that gives me 2. Raise your hand if you had that one right. Okay, that's one of your points. Okay, now how about sine of 60? Did anybody have that memorized nowadays? And this is pi over 3, yep. So sine of 60, also known as pi over 3, is root 3 over 2. Why does that work particularly nice on this problem? Because then the 2's will cancel, because 2 times the 2 on the bottom, and then it's just root 3 plus 1. That's what 3 plus 1. I get how that would be a pain to actually get the decimal for, but don't worry, we don't make you. That's all you'd have to write, because there's no calculators allowed in the test, period, at all. What? Good, yes, and 1.7 or 1.8, something like that, yes. All right, so next is, what's something different than pi over 3 and pi over 6 that works nice? Pi over 2, I like it. Pi over 2 is 90. Sine of 90, that's where 90 is. Sine of that is the y of that. The y of that, since it's 0, 1, is 1. So then I stick a 1 in here. 2 times 1 is 2, plus 1 is 3. Did you have 3, pi over 2? Good, that could have been one of your 3 points. You could have a zillion different things here, but I hope you're getting the idea. Yes, sir? You will have to have 6 points in the test, so you need to know the uncommon ones. You can't just do 30, 60, 45. But I just want to remind you, cosine of, for instance, the uncommon ones, it's really not that hard. Just do all the quadrantals. What's that one? What's that one? What's that one? What's that one? That's pretty easy. What's cosine of 0? Cosine is the x of it, and this spot is at 1, 0. This spot's 0, 1. This spot's negative 1, 0, and this spot's 0, negative 1. So again, if cosine is the x of each spot, then it's just cosine of this would be 1, cosine of 90 degrees would be 0, cosine of 180, pi would be negative 1, and cosine of 3 pi over 2, or 1.5 pi, would be 0. So those are some of the easy ones. That's 4 right there you could use out of your 6. Yes? Yes, yes.
So if we have to graph the ones, will we have to graph the ones that have like a square root number in them?
Yes, and if so, you'll be able to use an estimate as a decimal, and it won't be far off. You know, if you realize your patterns like this, oh, it looks like it's making a circle, and this one's off a little bit, it'll be not that big of a deal. I understand that gives you stress, and I can't make it better. Because there are going to be problems that involve the square root of 3. Maybe you should know that going in. You want to know it right now? Grab your calculator. Type in the square root of 3. What's the other big square root that comes up a zillion times? Square root of 2. Okay, so what's the square root of 3? 1 point what? 1.7-ish. Okay. And do you think I'd really mark it wrong if you said 1.6 or 1.8? I can't even tell the difference on a graph, right? Okay. As long as you get the idea that that's 1 point, you know, not quite 2. How about square root of 2? What did that come out to? 1.41. All right, cool. All right, now that you know those, you don't need a calculator. All right, let's move on. If you have more questions about it, feel free to ask me in a minute after I'm done with more stuff, because I got to get through a lot to get you ready, because it's a short math day, you know. So, all right, next thing is, let's say that I had two graphs. That's a polar graph. Assuming this radius is 1, what's the equation for it? In polar. Come on, super simple. R equals 1. How is that an equation? Because you can make an R theta chart and get a zillion options. Get it, theta doesn't matter. The angle doesn't matter. I'm always going to plot a 1, no matter what angle. In other words, for every angle, I'm just going to plot a 1. It's kind of like on the old y equals 3. If you were doing a rectangular graph, here's the line y equals 3. It doesn't say it, but x could be anything, and y is 3, right? Same idea for this. R has to be 1. The angle that we go at, this angle or that angle or this angle over here, that angle over there, the angle doesn't matter. The radius is always just 1. Okay, that's a polar graph of r equals 1. What if I had r equals 1 and r equals sine of theta, and I wanted to know where they overlapped each other? Okay, do you remember where r equals sine of theta ended up? We did it yesterday. How about this? Graph both of them. Graph both of them on the calculator. I think you'll know what the one of them looks like, but the other one you might be a little shaky on. Just one thing at a time. I'm showing people how it looks. So I want them to get that perspective. R equals 1 is a circle with a radius of 1, right? And you may want to zoom in on this when you're done with it. R equals sine theta is that also a circle? Yeah, but it's in a little different place. I'm going to make this a little bigger. Just, oops, hold on. Can't do pinch and zoom on smartboards, so let that a second. Okay, I'm back, and I've got my circle just a little bit bigger for my radius of 1. And now, correct me if I'm wrong, but I believe sine is another circle. I know the answer to this, but you tell me. Does it look like that? No. If it did, though, do you get it would have 2 answers, 2 places that it crossed? But I know how big sine gets. And you do too if you think about it. What's the biggest sine gets? Think about the wave. What's the biggest sine ever gets? So you get how it's the biggest it's going to get is 1, which is right there. Okay, and then sine on a polar graph does look a little different, and hopefully it looks something like that. Raise your hand if you got something like that. Okay, good. Did they ever touch? Yes. At what point did they touch? Be careful. This is a polar point. You can't just say 1. That point is 1 comma pi over 2. Awesome. That's where those crossed. Now, could you have done this without the graph? Absolutely. I think you had an idea on how to do that. Tell me what you would have done algebraically. Because you're not going to have a graphing calculator, so don't depend on that way. Oh. Because r is 1. Exactly. Do you get if r equals 1 and r equals this, then this 1 could go right there? 1 equals sine theta. And you just figure out what theta has to be. The problem with this method, and there's nothing wrong with it, it's just guess what people write for their answer. They say pi over 2. What's wrong with that? That's not a point. Okay? The solution is a point. It's something comma something. Okay? What was the radius there? Radius is 1, and therefore it's 1 comma pi over 2. All right, let's do another one that's kind of like that. Let's say we have a circle with a radius of 1, but we have this equation. Actually, let's make the radius 2. In this equation, r is equal to the if I just made it cosine of theta, pausing. Okay, so if I said this equation, do you get I need to say 2 equals cosine theta? Do you smell a problem with that? Can cosine ever be 2? That couldn't work. All right. There's no solution. They never cross. Exactly. If I were to graph it, here's a radius of 2, and here's where cosine is. I guess, have you caught on to this yet? Cosine was over here. All right. And cosine, the biggest it ever got was 1, and therefore it's not going to get, I probably made that circle even too big, but those circles don't ever touch. Therefore, there's no solution to this system of equations. Yes, sir.
What was graphing you can't?
That would be 1 over the other graph. Considering we're on the review day with only a few minutes left, let's not get into that right now. But all right, let's make this one you can actually solve. There we go. That one, cosine can be 1/2, and therefore these circles would cross, and therefore algebraically, not with a calculator, that's too easy. Algebraically, figure out the 2 spots where these graphs would touch. That would also be known as the solutions to this system of equations. I'll pause while you try that. Okay, here's the setup. R is 1/2, so the 1/2 goes here. 1/2 is cosine theta. I actually like to say cosine theta is 1/2 because that is a problem we've been doing for over a month now. It's just, okay, cosine's positive. I'm doing this on rectangular, just to clarify it. And nobody said I had to graph it to solve it. I am graphing a little picture of cosine on an XY graph. That's not R theta. This is cosine on a regular rectangular graph. Cosine's positive where that and that happens. So this is out and this is out. And there are 2 answers. This is not inverse cosine, you know, which would only be allowed up here. That'd be different. Okay, so the cool thing is for your final, we've been reviewing that circle trig this whole time. It's not going to be that hard to review for this final because we haven't just like did circle trig and then left it alone. We keep coming back to it. So it'll be a lot easier to be ready for this final, honestly, than your last final you had. Okay, cosine is adjacent over hypotenuse, and that's square root of 3. And what's across from the 1 is a 30. What's across from this is a 60. But we don't say 60, we say pi over 3. And then a whole bunch of pi over 3's to get down there. 3 pi over 3 for 5 pi over 3. So pi over 3 and 5 pi over 3. Raise your hand if you had that. Good. Is that the final answer? No, it's not. What do you mean it's not the final answer? Because you want the points. These aren't points. Those are angles. This is going to make it a point. It could. You're correct. But I am telling you, you should write your answers as points. Because then you're giving me all the information I could ever ask for by saying that. Any questions about that? Why did I put a 1/2 in there? Just because it says R is 1/2. We know the radius will be 1/2. It's because polar-wise, what we've got here is a circle with a fairly small radius intersecting with, was that sine or cosine we just did? Cosine? Okay, and cosine was this one. Is this cosine? I think that's cosine. Dang. Cosine's this one? Yeah, that's right, because the angles were like here and here, right? Or not quite there. Here and there. Anyway, so I have 2 points. I know they aren't perfect, but those are my points, and I wrote exactly what they were before. Any questions? That's called intersecting. That was the last thing you needed to know. Now let's practice one more thing. Well, you haven't done any changing this equation to that equation. This is polar. Oops, cosine theta. You can change that to rectangular if you know those 4 big equations. I said before there were 6, but by now most of you've got x equals r cosine theta memorized. Instead of having to go from this little triangle, instead of having to go, oh, cosine is x over r, most of you guys can say, oh, x is r cosine theta. Why don't you just, for review, write me the 4 big equations then. If you get 6, 2 of them just aren't solved, so all the polars on one side and all the rectangulars on the other. Write me the 4 equations that come off of this mother triangle, the mothership. Once you've got those, some of them will help you solve this. and make it from polar, make a rectangular equation. Notice I'm not asking you for a point. I'm asking you for an equation. Now, if you're thinking, well, I could replace r with something, that's the hard way. Who's got a tip? Yes, sir. Why aren't you squaring? That's not going to be handy. Good. But timesing by r is. Now I've got r squared, makes x squared plus y squared, and r cosine theta can be replaced with, and that's in rectangular. Remember that? Okay. So, what if I give you one in rectangular? And you had to change it into polar. Rewrite this so that it's in polar. One last thing. When things are in polar, you either have to solve them for r or for theta. So whatever you get, solve it for r or for theta. I'm going to pause for a second and give that one a try. All right, so this last problem I want to just show you. If you go from 12 comma negative 2 to 20 comma negative 2, can you tell me the amplitude? No, because the amplitude, I would need to know how low this thing goes, and the amplitude would have been half of this. What could you tell me? From this to this, I could find something else. You could find the period. The period is how long does it take to get from a peak to a peak, or a valley to a valley. In this case, it's the x distance, which is 8, so the period of this thing would have been 8. Okay, that's all the review I have for you for today.